Hello, everyone, and welcome to what I hope will be a kind of fun talk. And I'm really sorry that I can't be at Scot-Secure in person, but I'm hoping that the talk will be entertaining for you all nonetheless. So I've kind of called this talk "Your Technical Debt is My Bug Bounty," which I thought was a fun title. Essentially, I'm going to tell you a bunch of stories about some of the vulnerabilities I found in real software in use every single day and just talk about how I found them. I really hope that you can take this and maybe be inspired to have a go at hacking yourself. I promise it looks really hard. I promise it's not as hard as it looks. And yeah, so with that, first things first, who am I? What right do I have to be speaking to you? My name is Katie Paxton-Fear. I go by Insider PhD on basically all platforms. I'm a lecturer in cybersecurity at Manchester Metropolitan University. But if you know me, you do not know me for my academic work unless you're a student of mine. You probably know me because I'm a hacker and probably because I'm a YouTuber. Like, follow, subscribe. But I got into bug bounty hunting during my PhD. I was really fortunate to be invited as a mentee at a live hacking event. And that's where they bring the best hackers from all over the world and me, apparently, to one place and get them to hack on a single target. So essentially, I hack companies for money. It's completely legal. The companies let me do it. It is all it's all intentional. And ever since I kind of went to my first event, I discovered a really interesting love of hacking and realized I, as like a former developer, actually was very good at this despite not really knowing what I was doing. Since then, I've found over 30 vulnerabilities in organizations all over the world. I give a lot of talks, I give a lot of training, and generally help people become hackers, especially people who aren't necessarily hackers themselves. My biggest achievement, more so than the PhD, is actually teaching my mum how to hack. My mum is terrified of computers. She doesn't know how to connect her Bluetooth headphones to her phone. But I actually got her hacking, and yeah, that was really fun. So, if you've never heard of bug bounty, I don't blame you. But I was watching a YouTube video once of these iceberg videos. They were very popular a few years ago. And it was the rabbit holes iceberg. And for everything from dark stories like creepy pastas and then bug bounty hunting was on the list. And I was like, oh, okay. I guess this is more niche than I realized. So essentially how it works is that I get invited by companies to I hack them, I send a report, I tell them about how I did it, and I get paid per vulnerability I find. Now, this is different to something like pen testing, where, I'd be paid for my time, I'd have a contract. It's basically hacking freelance. If I don't find anything, I don't get paid. And the kind of companies that can run bug bounty programs are very, very mature companies. They're people who have a security program who can accept and resolve these issues. So think, big Silicon Valley companies, not local accounting firm, right? So these are companies and targets that are mature, that they have very constant AppSec programs, etc. And, this is just some fun bug stories. I wish I was the super elite hacker with amazing technical skills. My background is in machine learning, and you might think, oh, that's popular now. I do not have insane technical hacking skills. What I can do with the R programming language, yes. But actual hacking skills, no, not so much. And instead of talking about some really cool, really technical, really interesting vulnerability, I'm going to show you some easy to find bugs that required, at least on my end, more thinking than anything else. So if you don't already know me and kind of what I do, I mainly focus on API hacking. And that's because back when I was a developer, I was essentially writing APIs, very basic kind of RESTFUL CRUD APIs. And so for me, when I started hacking in this brand new world of actually seeing what an HTTP request and response looked like for the first time, I kind of went back to what I knew. I can make APIs, that means I can break APIs. Now, a lot of people think API hacking itself is a new type of hacking that you need to be. It's literally not different from any other kind of web hacking. The websites that I see, I look at mainly text, rather than, having images or JavaScript making buttons appear. They look different, they have a different use case, they might look a bit scary, but they are fundamentally a website. The vulnerabilities between a website and API are not wildly different. APIs just tend to be good places to start, and especially in a bug bounty context where you've got a competition element. So with bug bounty hunting, you have a first to find. If I find a security vulnerability after somebody else, I don't get paid for it. Less people are looking at APIs, therefore I'm more likely to find bugs there. So why APIs? It's very, very common for mobile apps and web apps to have APIs now. We have things like developer APIs like the Twitter API, but also just general, you don't want to write code twice for a web application and mobile application, write an API and they both can access that. There's new technology in APIs like GraphQL that are fundamentally changing how APIs work to a quite a substantial difference. So back in ye olden days, we had, SOAP APIs and XML, and then we transitioned to RESTFUL, and now we're transitioning into more query language style APIs like GraphQL. Generally, other hackers have less familiarity with APIs versus regular web applications, which means bug bounty context, I'm more likely to find stuff. They have a really large attack surface. Often for a single resource on, say, Twitter, you'll have a tweet, you'll have messages, you'll have timelines, you'll have people you follow, people who follow you. And by the time you put all that together, it can very easily get out of control. And again, this goes to the competition element of APIs. That is to say that if there's a large attack surface and people are less familiar with APIs, I've got a better chance of finding something. A lot of APIs nowadays, especially with modern technologies, actually tend to be generated rather than being designed. And this is a really good trend for developers because for developers, they often just need to set a few parameters and then all this large attack surface, bam, done. 100 API endpoints deployed and ready. But actually, for me as a hacker, that's where I tend to find mistakes. Not necessarily code that a developer has written, but a code a developer has kind of just deployed after being generated. APIs can be really intimidating for other hackers. It uses plain text, looks a bit scary, but fundamentally, it's not any different. It's just you're working with different data. A lot of fixes in APIs tend to be on the client side. They don't tend to actually fix the root issue. They'll fix the website, they'll fix the mobile app, but they won't fix the server-side API flaw because they want the API to not necessarily be bogged down with what they consider to be client-side issues. But that doesn't actually fundamentally change the fact that the API itself is still vulnerable. It's really easy for APIs to get completely out of control. In terms of complexity, I'll often have a spreadsheet open. And again, this is where that aspect of competition and, lack of familiarity can really get to people because it's super overwhelming. So API bug hunting, roughly I can categorize my bugs into two broad categories. First is issues between the interface and the API, aka the mobile app shows me data points A, B, and C, but the API returns A, B, and C, but also D, E, F, G, all the way to X, right? So essentially, the API returns more data than whatever UI, whether that's a mobile app, whether that's a website, actually shows. And access control issues, you're able to do something to a resource that you shouldn't be able to for whatever reason. So the issues I like to test for: access control issues, mass assignment, information disclosure, and business logic errors. So the first one, I can access other people's stuff. I can like a tweet on their behalf. I can send a message from their account to another account. I can delete a tweet of theirs, whatever. I can use something, an edit profile API endpoint, to do something like edit a password where you usually need password confirmation. I can see PII or something similar. Tends to be less PII nowadays. It tends to be more upstream functionality, essentially. You can kind of see more information the application typically does, and literally everything else, random stuff. So, sounds super complex, sounds like I know what I'm talking about. So, let's actually look at the first bug here. And I called this one working as intended. It's convenient, but is it secure? So, this starts out with a target where you could essentially have an event and request flybys of craft. So you can kind of imagine, maybe it's the red arrows, right? I don't know, it's probably not someone's 60th birthday party, but maybe someone's going into retirement. They say, oh, I'd love this particular old aircraft to fly over my house so I could see. Essentially, it's what this application would allow you to do. And in this application, you would set things like the nearest airport. And obviously, it would be your responsibility to get things to land there and stuff like that. So here's a question. What happens if an aeroplane is too big for a runway? Now, quite often runways are very, very large, and most aircraft, especially in the UK, can land at most runways. But you think about our smaller regional airport. My family's from Middlesbrough, so I'm going to use the example of Teesside Airport. It's small. You're not going to land a massive 747 at a small regional airport, right? It's designed for much, much smaller planes. And if the runway isn't long enough, simply the plane will keep going. This, by the way, is the airport in Kathmandu, Nepal, where it literally goes off of a cliff. So this application, as we were testing it, you could make a request and edit a request, and it didn't require a username and password. And this is super convenient because you know what? If you don't need a password and a username, your users aren't going to forget that. You don't have to deal with having a full account system. The problem is it let you use your email address. As I'm sure quite a lot of us know, an email address is not any kind of secret information. That is fundamentally public information. Nobody considers that PII, really. And so when we were looking at this and we put in logged into an account, created a request, you could give a lot of information about it. So things like the event title, is it an show, but also the site elevation and the runway length and width, and is there an arresting gear, and the media coverage as well. But this is quite interesting, right? Because like I said, if a runway is too short, the plane will simply keep going. It doesn't stop at the end of the runway, right? And you can kind of imagine how bad this would be. All you need is somebody's email address, and you could see their request, change the runway to be much longer than it should be, and it actually is in reality, and essentially force larger planes to, or put it in a position where these larger planes would be landing at this very small regional airport. And this has quite big considerations for human life, essentially, right? Like an air crash is not going to end very well. And for our trouble with this, we got a very small bounty, but we did split this with another person. And actually, what we did was far less work from what they did. So I was okay with this bounty. It was fine. So that's the first story. The second story I've called is Read the Docs. And this is probably one of my most technical bugs. And it's one of, I think, the most fun bugs that I've ever found, especially as a software developer. So essentially, I was able to use an API request to figure out the exact software version, not of the API, but of a dependency of a dependency of that API. So GraphQL APIs, I kind of mentioned them at the start, but there's this new technology where in a RESTful API, you would have 4 distinct endpoints for each CRUD functionality. So you'll create, read, your update, delete, or 5 because you might have a read all as well. GraphQL instead has its own built-in query language. So you can write queries and mutations, which are just queries that change stuff. So you write your query and mutation, and then you send it to a single endpoint. And then what it does in the API is kind of up to them. So it is essentially a single request API, but it's kind of interesting. It's new technology, so there aren't necessarily good resources out there for looking at these issues. So as I was testing this, I saw this, which is multi-part form. Now, multi-part forms are used very commonly in requests. So a multi-part form will essentially allow you to submit the form and then something else. So an image to upload to a profile picture, for example, or a file that you want to send. And these are very, very common. However, this one was a GraphQL multi-part form. And this is weird. I had never, ever seen something like this before. I see multi-part forms, I know GraphQL, I had never seen them merged in this way. So you can kind of see this. I just changed this to be a laser pointer. So this query, so that's the start of our GraphQL. This is the mutation, so that's the thing we want to edit. And you can see we have this variable file here. And at the very end, we have file and then null. Then we have this map part of the form, which then says 0 is variables.file. So it's referencing this variables here and this file here. So this is null until this comes along and fills it in with index 0 of what? Well, the next part of the multi-part form. Basically, it's kind of weird. I had never seen an application do something like this before. And this is very distinct, right? So when in doubt, we go to Google. So I was having a look at this GraphQL multi-part form, and I found out it's actually a specification that's being developed, and it's not necessarily standard at the moment. It's just a kind of suggestion. And in terms of where they're at, it's kind of different depending on which server and then which language you use. So, okay, this is interesting. Unfortunately, for me to work out what the GraphQL server was, I would need to have to narrow it down because at the moment, I've got an option of any of these. I don't want to go through each of these individually. They're going to have very different vulnerabilities. They're very different programming languages. So as I was testing this and messing around with it, I was able to cause this, which is a Java util concurrent execution exception. Okay, it's running Java then. Great. So we can take that big long list and actually start to narrow down the options. Now, thankfully, it wasn't JavaScript because JavaScript had 4 options. And actually for Java itself, there was only 1. So great, narrowed down the options. So found out that this server was running GraphQL Java Servlet. A quick kind of security researcher thing, you go to the GitHub issues and you type in, security, CVE, etc. So great, right. 48 vulnerabilities from Jackson DataBind. So this comes from, and in fact, the same thing that happened to me, that this is an old version, is the 6.1, but they're on 12.0. Now, the interesting thing about Jackson DataBind is that it's got a lot of security issues, but it's also got a general large amount of bugs in it. So what I was able to do is look into Jackson DataBind and start to see what bugs I could target. So I'd go through the GitHub issues, look at the major releases, and then look for kind of basic bugs. Can I put a pound sign in, for example? Will it let me use a dollar sign? What happens if I put in a quote? And seeing how the server reacted to that behavior would tell me what version of Jackson DataBind they were or were not using. So if I'm looking at version 2.3, if I can cause a vulnerability or any kind of bug, not just a security bug, from 2.1, I know that even though 2.3 might be the latest, they are using at least 2.1, right? I can keep going further. So does 2.0 have this one bug in it? Like maybe it doesn't pass special characters correctly. And I can start to really narrow down what version of Jackson DataBind this Java servlet, GraphQL Java servlet was actually using. So had a look, did some Googling, and we were able to get a nice bounty from this because We were able to work out which version of Jackson DataBind, use a known exploit for it, and it just worked. So that was really cool to see. Now, I should say, for a lot of companies, they may not pay that because it is in a third party of a third party. But this contextually was on a big company who could absolutely update the software. And it was kind of on them to do that. And it's something they cared about regardless. So that was a nice 2K bounty for that. So the next story is called Thinking CRUD. So CRUD is this very common acronym we see a lot. It means create, read, update, delete. So an API and a RESTful API, you have a single request for getting all of a resource, getting a resource with a particular ID and viewing that, creating a new resource, editing a resource that already exists, or deleting a resource. And because RESTful APIs have this really, really common structure, you can spot them instantly, especially once you start to do quite a lot of API security. And so we can see this in action. We have the view button, the edit button, the delete button. So, we can view something, we can edit it. We can also view the actual information about all of the resources available, right? You can imagine these are like addresses. We can view every address in the table. We can view a single address. We can edit an address or we can delete the address. So edit forms often look like this. You have some form and it will pre-fill it in with some information, right? You don't need to write your name in again. You just need to change the misspelling or whatever. So what I was looking at was this edit form on a social media website. And this wasn't YouTube, but I'm going to use the example of YouTube. So it was on something like YouTube. Wasn't videos, but it was similar. And when you clicked on edit, you were able to go in and, change the title or whatever. And you could do this even on an account that didn't own that video. So you can imagine that you would be able to get to the edit form for my videos, but you wouldn't actually be able to edit them. Once you clicked OK, it'd be access forbidden. You are not the right user for this. So it's fine, right? Well, no, because it's pre-filled in all these details. Now, a lot of videos on YouTube are public, right? You can see the title of a video, the thumbnail of a video. It's just available. But if the video is set to private, then you shouldn't be able to see the title, the description, or the thumbnail, right? It's set to private. And when you edited the video, even if you didn't have permission to actually edit it, you could still see that private video and still be able to work out what it was about. And it's an example of PII really, or information disclosure, but it's kind of an interesting way to go about things. And again, I got a pretty nice bounty for this. So the final story I have for you all today is quizzical. So this idea of balancing performance of apps against security concerns. And as security people, this is something we're intimately familiar with. This is our job. This is what we get paid for. The job is not do security. The job is the balance between security and performance or business needs. This was a quiz application. And it was, have a quiz, select the right answer. Yeah, you get points. And you could exchange these points for Amazon reward cards. You can kind of imagine a survey filling out website kind of deal, right? You do 300 of them, you get a £5 Amazon gift card, right? Now, the interesting about working with mobile is the efficiency, and that's because your phone uses a battery. So if you didn't know, this is actually from Google's Android documentation. A lot of applications are required to optimize network access. And that's because the weight radio in your phone, the actual thing that sends signals, cannot be active all the time because it will absolutely drain your battery. So instead, the way it works is it transmits for 1 second, is on full power, and then goes into a low power mode. And this repeats every few seconds. It doesn't seem like a lot, but it really helps deal with things like battery drain issues, but also data consumption as well. So to kind of combat this, Instead of sending 3 different API requests that will keep the antenna running for longer, a lot of companies implement something called batching. And batching essentially says, well, instead of sending 2 requests, I'm going to send 1 request that has these 2 in them and then send it back. So essentially, what you get is this very intimidating over here looking request where you've got not just the API endpoint itself, but also, stuff you'd expect to see, things like how much the checkout is, but also, what the headers are for that request. And it makes for kind of an interesting approach to actually developing and looking at an API. So again, this was a quiz question, and you can kind of imagine that the request here would be a quiz, type quiz question. What is the capital of the UK? Is it Paris, Berlin, or London? And obviously, we don't want to overwhelm the battery or make a lot of unnecessarily requests. So what we'll do is we'll just send a correct answer also in that API, instead of having a request for getting the quiz questions and a request for knowing whether or not they're correct. We'll just include them together. Now, some of you may realize that if we put all this together, that we've kind of got this interesting automation we can start to build, right? Because what we have is a way of seeing all the quiz questions, of seeing which one is the correct answer, submitting that answer back, doing that 300 times to get our £5 Amazon gift card, and sorted. The problem is that that system can be incredibly easily automated, and you can essentially generate free money from it. Now, unfortunately, it's a duplicate, so I only got a $50 bonus. That happens. That's bug bounty hunting for you. Sometimes it happens. So that's kind of the end of my stories, but I wanted to wrap it up and think about, what does this mean for APIs and kind of the future of API security? This is the thought leadership section. Most API hacking is more thinking than technical. And I think when we'll start to, think about vendors and stuff like that, a lot of them are selling security products that don't have this holistic approach. And that's why these bugs get left in, because a kind of bot can't figure it out. It's more about that human thinking, that human reasoning, that further context. Saying that, of course, it does require some technical skills. If you want to do Android hacking, you need Frida installed. But fundamentally, I don't think that APIs are something that, one, are very easily solved, and two, that we need more people to be thinking about things, right? We need more people to be looking at these APIs and finding that critical reasoning. If you'd like to learn API hacking, I'm not going to get too much into it in this talk. However, I do have videos on YouTube teaching you how to get started with API hacking. I have a playlist called Everything API Hacking that goes through it from zero to nothing. And I think this represents, and APIs in general, represents this larger problem in security that we have, which is that fundamentally, systems are no longer designed. Nobody is thinking about inputs and outputs, but they're instead this mess of APIs, no code services, if this, then that style services. We now have AI coming along, and fundamentally, people are selling products that are a wrapper around OpenAI's GPT API. That race for new and shiny often means limited security or relying on a collection of SaaS. However, we have this really interesting problem, which is, where does your responsibility actually start? What is a you problem and what is your third party's problem? Those weaknesses between services, for example, are where we're going to see more security bugs. A lot of people assume that APIs are this solved problem, that, AI is the next big security risk. But actually, the weaknesses between security, things like people being able to use prompt injection on Bing Chat to get its prompt, for example, because it's fundamentally just sending a prompt to ChatGPT's API. It makes for an interesting problem space. So we actually did an academic study on this, and we spoke to a lot of experts, both security and generally technology, about this connected systems problem. And we came up with a few predictions from that. A lot of people spoke about things like AI and generative AI, and spoke about a lot of the security issues involved with things like AI, even to the point where they could name specific security bugs. The problem is no one was really thinking about this interconnectedness, that a lot of people are thinking AI security is, brand new bugs. People are obsessed with new bugs like prompt injection, but aren't getting down to those interconnected environments, the decentralized, SaaS focused environments we all live and work in. And if you take nothing else from this talk, I hope you have taken that. So if you've got questions, you are very welcome to reach out to me. My email is katie@insiderphd.dev. You can find me on social media as InsiderPhD or on LinkedIn as Katie Paxton-Fear. I'm on Mastodon and Threads as well. And if you'd like to reach out for things like sponsorships or business stuff, sponsors at insiderphd.dev. If you have any questions or want to chat or think what I'm talking about is interesting, please do connect with me. I'd love to chat further. So I hope you have a great conference, everybody, and I will hopefully hear from you all very soon. Thank you very much for listening.